Okay, this is Wednesday, Thursday homework. It's going to be due on Monday, Tuesday. We're doing inverse functions today. And hopefully you remember this from Algebra 1 and Algebra 2. And we're going to talk about how to go through these notes. So the things we're supposed to learn today is find the inverse of a function both formally and informally, and verify that the functions are inverses. Then we're going to use a graph and see if the functions are inverses of each other. We're going to use the horizontal line test to determine if a given function has an inverse. And we're going to find inverses algebraically. So basically inverses, if you have an x, for every xy that you have on the original graph, if that's the original graph, the inverse points are just flip-flopping those. So whatever your y was in the original, your x is now the y value from here. Whatever your x was in the original is now your y value in your inverse. So you flip-flop the ordered pairs. That's what makes functions inverses. So something that you're supposed to know is, maybe you've heard of Fogg and Goff back in Algebra 2, but if you take a function and stick it into another function and you get the value of x out, and then you flip-flop that order and stick the first function into the second function and get x out, if both of these things are true, then these f of x and g of x are considered functions. And the way we write the inverse of a function is we write it like it's f, and we put a -1, almost like a power of it. So this is read as the inverse of f right there. This part is the inverse of f. So this is the inverse of f of x. So they're saying that if you have a function f and you stick the inverse into that f function, you get x out. If you have the inverse and you stick f of x into the inverse, you get x out. So it's kind of the same thing that was Fogg and Goff back in the good old days. Okay, a horizontal line test is how you check to see if a given function has an inverse. So like if you have a graph, let's say we do the cubic graph that we learned in class this last week. If you do the cubic graph, now you can tell if this graph is a function from the vertical line test. So if you go up and down this vertical line test, the cubic is a function. We can tell if the inverse of this is a function by doing a horizontal line test. So if you take a horizontal line and you start at the bottom, you go all the way to the top, and if it does not repeat, if in other words there's no intersections, then this would mean that the inverse is also a function. Now, if you had a graph that looked like a parabola, now a parabola is a function itself, but if I do a horizontal line test, then this parabola, the inverse is not a function, or there is no inverse. Okay, there's no inverse because the inverse, it hits in two places at the same time. So a horizontal line test checks for the inverse, whether or not the inverse is a function. And this is basically saying the same thing about, for a regular function, you look for the x's repeating. For an inverse, you look to see if the y's in the original one are repeating. If y's repeat, it's not a function. Now, to find the inverse of a function, you are supposed to flip-flop the x and y function and then solve for y. And then you would put the inverse notation back in. And I think we're going to do one of those in a little while. So this one right here says, using this table to find an inverse function in 35 and 36. Well, you're doing 35, so I'm going to do 36. So if I do the inverse of this function in 36, I think I'm going to do it. I'm going to do it right here below. So in other words, this is x, and this is the inverse of x. I'm doing this 36 one. So all you do is what I said earlier, is you just flip-flop the numbers. So you put the 10 goes top, the -3 goes for y. The 5 goes for x, the -2 for y. The 0 for x, -1 for y. -5 for x, 0 for y. -10 in the x, 1 for y, and -15 for x, and 2 for y. So this right here would represent the inverse of this 36 function. Now, if you wanted to check this before you even did this, if you want to know if the inverse is a function, all you do is look and see if any of these repeat. Since none of these y values repeat, which if you write it as an inverse become the x values, This tells you the inverse is a function. And I'm telling you that because that's how you do number 33. I did not put that graph on here. Okay, going on down here, you want to choose a horizontal line test. So 38. So since this hits two places at the same time, there is no inverse function. If I do 40, there's nowhere that if I move that red line up and down horizontally, there's nowhere it would hit twice. So this has an inverse function. The problem's at the bottom going on. It says here, applying the horizontal line test. Now you're supposed to use a graphing utility. So you're going to type this equation into your function or into your y sub 1 equals and graph it. And you're going to do the same with this one. And you're going to graph it, and then you're going to look at it like this horizontal line test to tell whether or not it has an inverse. Okay? Now these down here at the bottom, you got 45, 47, 49, 51, and 53. It says down here, find the inverse of the function f, graph both f and the inverse on the same set of coordinates, and then describe the relationship between f and inverse of f. State domain and ranges of f and inverse of f. So I am going to do number 46 for you right now. So when I do 46, 46 says y equals x cubed plus 8. So it starts off f of x equals x cubed plus 8. So the first thing you want to do is make this y and rewrite it like this. So this is the same function as the one above. Now to find the inverse, you're going to flip-flop your x and your y. So you're going to bring x over here, and you're going to put the y in where the x is, and now we have to solve this graph for y. So I have to subtract 8. And then I have to cube root each side because the graph, this graph over here is a cube. So when you cube root it, you get y. You don't put plus or minuses when you cube root. Anytime you have an even power, you're supposed to put plus or minus. Whenever you have an odd power, you just keep the sign the same. So this is the equation. So the inverse function, you put this back in place of the y, is equal to the cube root of x minus 8. Now we're supposed to graph both of these on graph. Well, what I know is, I know what the x cubed graph looks like. And I know this plus 8 is a vertical shift up 8. So I'm going to come up here to 8, and I know that the x cubed normally goes through 0, 0, but it's going to go through 0, 8 because of vertical shift up 8. And if you go up 1 over 1, there's a point there. And left 1 down 1, there's a point there. And then it's up 7 and 8. So this graph is going like this. Of course, erase the whole thing. Okay, so that's what the original, that purple is the original graph. And then I'm going to graph this one in, this one in black. So this is a cubic graph. And since it's got minus 8, that means it comes out here to 8. And that's where it crosses this graph right here, because that's a horizontal shift right 8. And I know it goes up 1 over 1 for a dot here, and left 1 and down 1 for a dot here. And this graph goes like this. Now, something I've not told you yet is that inverse graphs are symmetric to the line y equals x, which is goes through a y-intercept of 0 and has a slope of 1. So if you fold a regular function, this is the inverse function, this is the regular function, you should be able to fold them over the line y equals x, and they should land on top of each other. So that's what those two graphs look like. Okay, so then state the domain and range. Well, I hope we know a cubic's domain. I'm going to do this one first, the regular one. There's no value that x can't be, and there's no value that y can be. It goes up and down forever. Likewise, when you're doing the domain and range for the inverse function, do you remember we flipped the x and y's? So whatever the y range is for the original function, that becomes the domain for the inverse function. And whatever the domain is of the original function becomes the range for the inverse function. So they are both negative infinity to infinity. So that is what you're doing for your homework for Thursday. We're going to turn that in Monday, Tuesday. And we're also turning in that Friday worksheet. That is what you're doing for your e-learning day. So I'm signing off for now, and I will see you all on Monday and Tuesday. So have a great day and a great